presenting it. So this is the concurrent shift with a belt-like action. These two things, extension and extension, are going to occur at the same time, as you know, just reviewing, in order to get us to that position, fighting gravity. And this hamstring, during this movement, simultaneous movement here, guys, it doesn't have to change length much. And the same thing can occur over here. It doesn't have to necessarily change, it doesn't have to undergo any version of severe eccentric or concentric. So this and that could stay the same length because they both moved. Now here's the hiccup in the deal, and I'm going to show you this a little closer to the camera, a little split screen thing. But what I'm just going to attempt to show you now is there's a different, and certainly in my model there's a crazy difference, but there's a different potential length of the point of attachment to the axis of each end of these muscles. Now mine's not accurate because it's a model and I'm avoiding a metal hinge and that kind of stuff. But anyway, the proportions of movement, joint movement, performed relative to the various and differing distances of attachment from the axis at each joint means that there is very likely to be a little bit of shortening depending on how you move, a little bit of lengthening depending on how you move, and what happens in one side, it may be shortening a little bit based upon those features I just mentioned, while the other side may be lengthening a little bit. But the point is, there's an efficiency created, a true mechanical efficiency, a muscular energy efficiency by having this transference of force. So what would that look like? Well, this is the belt-like action. And if you were lowering, you would get the reverse of that. So now we're going from there to here. And so we'd have this guy shifting more around, this length will end up more around this joint, this by bending. You see what I'm talking about? And the model again will help. But this force transference is interesting because if I consider the glutes to be the primary, major, super awesome, and they are, hip extensor, when required with the right direction of resistance. And if they actually extend the hip, and this guy stays relatively isometric, this knee has to straighten also. And I'm going to show you in the model how that works because I'm going to take the rubber band thing out of it and I'm going to tie it with string or wire. And that can't change length. Models are a good way, they're never accurate like 100%, just like, you know, when you're looking at a model of an atom and there's like little wooden electrons stuck to little tinker toy looking pegs. It's a model that serves its purpose. It's not meant to be, this is what an atom really is and how it functions. So models need to be taken in context. But similar thing here, if I extend my knee and consider that vastus group, the single joint group, and that as it extends the knee, if this hamstring group is isometric, then it's going to drag the hip into extension along the way. So main power mover resistance fighter, this is going to be our tether, if you will, this time. Now, the thing is, all that happens in concert. And again, you can bend more at the hip and you can bend more at the knee. We have the ability to manipulate the idiosyncrasies and the exact details of squat mechanics a little bit, like what happens more where, which will adjust this. But the general idea is that as these two far more powerful groups of muscles, due to their everything, cross-section, fiber arrangement, everything, moment arms, you name it, these guys would transfer hip extensor force to knee extension and knee extension force to hip extension. Like bicycle chain, if you will. Transferring what happens here at the pedals to the back tire and vice versa. Two sets of pedals.